Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values as a function f of t equal t minus cubic root of t on the closed interval from -1 to 4. First, we know that f is continuous on that closed interval, and for that reason, we know it attains its extreme values over that interval. And we know more than that the extreme values are attained either at the endpoints of the interval or at critical numbers of f. So we gotta find the critical numbers of f. For that, we calculate first the first order derivative of f, and that's 1 minus uh, the derivative of cubic root of t is, if we write that as t to the 1/3, is 1/3 times t to the 1/3 minus 1, and that is 1 minus 1/3 times t to the negative 2/3. Okay. T to the negative 2/3, and that's equal to 1 minus 1 over 3 times t to the 2/3, and that's the expression for the first derivative of f, and this derivative at 0 does not exist. It's not defined there. Now 0 is a point in the domain of f. In fact, f at 0 is 0. And because 0 is in the domain of the function and the derivative of f does not exist at that point, we can say that t equals 0 is a critical number of f by definition. Now we got to solve the equations f derivative equals 0. And that's equivalent to 1 minus 1 over 3t to the 2/3 equal to 0. And that's the same as 3t to the 2/3 equal 1. And in fact, this is the same as t to the 2/3 equal 1/3. In fact, we got to consider all the way through these equivalences here. We got to consider t different from 0 in order to write this expression like this. Okay, so we know that this is the case because t equals 0 was already treated separately here above, where we say that there is no derivative there, and for that reason, and the point being in the domain, we know that that value of t equals 0 is a critical number of f. So we have this equation here. We can say that this is the same to t squared equal 1/3 to the third power. And here we have two solutions. T equal more or less 1/3 to the third. Square root of that, of course, let's say. And that is more or less, we can write this as 1/3 to the 3/2. And we have two values, and the two values here, let's say this is about, in order to have an idea, of 0. Um, 0. Sorry, 19.245. That's t to the 1/3. That's 1/3 to the 3/2. And both values are in the interval from -1 to 4. So both of them have to be considered. So we have three critical points. Has three critical numbers in -1, 4. which are t equal negative 1/3 to the 3 halves, t equals 0, and t equal 1/3 to the 3 halves. That's the three critical numbers of f in the interval negative 1, 4. And now we got to evaluate the function at those critical numbers and at the endpoints of the interval negative 1, 4. And we get the following. First, at the endpoints, f at negative 1 is equal to negative 1 minus negative 1 minus cubic root of negative 1, that is negative 1. Cubic root of negative 1 is negative 1, and with this minus here in front of the cubic root is plus 1, that is 0. Okay, so now f at 4, which is the right endpoint of the interval, is 4 minus cubic root of 4, and this is about, in order to have an idea of the value, 2.412598948. And then we evaluate at the three critical numbers, f at negative 1/3 to the 3 halves, this one here, is negative 1/3 to the 3 halves minus 1/3 to the 3 halves to the 1/3, because the cubic root of the number is the same as putting it to the power of 1/3, and this is the same as negative 1/3 to the 3 halves plus, because here I forgot the sign, sorry, here. This negative here inside, here in front of the parentheses here, is this negative of the formula of the function. And then we have the cubic root that is raising to the 1/3, the number where we are evaluating, which is negative 1/3 to the 3 halves. So I forgot this negative sign here. Well, and now because the cubic root, we have the result is negative, with this negative here out is plus, is the plus sign, as a result. We get plus 1/3, and the power end up being 1/2. Okay, so this is about, this number here is 0.38 49. And now f at 0, which is the other critical number, is 0. And f at 1/3 to the 3 halves is 1/3 to the 3 halves minus the cubic root that is raised to the 1/3, the number where we are evaluating the function, that is 1/3 to the 3 halves, and that becomes 1/3 to the 3 halves minus 1/3 to the 1/2, and that's about negative 0.3849. So from these values here, from these 5 values, we got to find the maximum and the minimum values of the function. We know that these are, the maximum value is 2.41 at the right endpoint 4, and the minimum value is this one here, negative 0.3849, about that, at 1/3 to the 3 halves. So with that, we can say the answer to the problem. Then the absolute minimum value of f in the interval from -1 to 4 is 2.41, and 4 is 4 minus cubic root of 4, which is about, that's the exact value, but to have an idea of what value it is, it's about 2.41 to 598 to 598,948. And that absolute minimum value, sorry, I mixed up. Sorry, I mixed up the answers here because I'm talking about the minimum. I wanted to say the minimum value. We set this one here. So I made a mistake here. Sorry. So the minimum value of the function is negative 0. Is 1/3 to the 3 halves. 1/3 to the 3 halves minus 1/3 to the 1 half, which is about negative 0.3849. Now is correct, which occurs at 1/3 to the 3 halves, which is in fact one of the critical numbers. At the critical number t equal 1/3 to the 3 halves, and this in fact is about 0.19245. And the now the absolute maximum value of f in the interval -4, 1 is, now is the value I said before, is the maximum 2.41. That is 4 minus cubic root of 4 is 4 minus cubic root of 4, which is about 2.41 259 8948, and that value occurs at the writing point of the interval t equal 4. So the final answer, which is this one here, this sentence here, says that we have an absolute minimum value of the function of 1/3 to the 3 halves minus 1/3 to the 1 half, and that's about negative 0.3849, and that occurs at the critical number 1/3 to the 3 halves, which is about 0.19245, and the absolute maximum value of f in the closed interval is 4 minus cubic root of 4, which is about 2.412594848 and that occurs at the right endpoint of the interval t equals 4. So we have the exact values, extreme values of the function, and the exact values in the interval -1 for where they occur.